Imagine, if you will, the vast blackness of space, suddenly parting, like a curtain, in a grand theater, revealing a behemoth that defies every rule we've scribbled in our astronomy textbooks. It's October 25th, 2025, and the stars above us are whispering secrets we can no longer ignore. A colossal visitor, C/2025, R2, Swan, has slipped into our solar system, its presence announced not with a fanfare, but with a glow that spikes through our instruments like a heartbeat gone wild. This isn't just any space rock. It's a giant, with a tail sprawling 2.5 degrees across the sky, equivalent to 5 full moons lined up, dwarfing the Manhattan-sized 3I/ATLAS by factors that make your head spin. Picture it, a shimmering entity, larger than cities we've built, hurtling through the void with a grace that feels almost intentional. As I stand here under the night sky, feeling the chill of autumn air mix with the warmth of wonder, I can't help but feel a deep, primal stir in my soul. We've always looked up and wondered if we're alone, but now the universe seems to be answering back, not with words, but with these enigmatic messengers. Swan was first spotted on September 11th, 2025, through the vigilant eyes of the SOHO spacecraft's SWAN instrument, designed to track solar winds, not interstellar intruders. Yet there it was, its brightness exploding in readings thousands of times beyond the norm, turning a routine scan into a moment of cosmic drama. It's like the universe decided to crank up the volume just when we thought we had the playlist figured out. What grips me most is the emotional weight of this discovery. In a world where we chase fleeting trends and digital distractions, here's something eternal. Something that reminds us of our tiny place in the grand tapestry. It's humbling, exhilarating, and a tad unsettling, all at once. If this tale of celestial wanderers pulls at your heartstrings like it does mine, smash that like button to show the universe we're listening. And drop a comment below. What would you do if you knew something this massive was watching our world? Let's build this conversation together, sharing our awe across borders and cultures, because this story belongs to all of humanity. But let's not rush ahead. To truly grasp SWAN's arrival, we must rewind, tracing the thread of visitors that paved its path, each one stranger than the last, building a pattern that feels less like coincidence and more like a cosmic narrative unfolding before our eyes. The universe has a knack for delivering lessons in humility, doesn't it? Just when we pat ourselves on the back for mapping our solar neighborhood, along comes a series of uninvited guests that rewrite the script. It all started back in 2017 with one I/Oumuamua, that enigmatic cigar-shaped wanderer from beyond our stars. Roughly 200 meters long and weighing around 100,000 tons, it zipped through our system like a scout on a reconnaissance mission, its elongated form tumbling end over end without the dusty tail we'd expect from a comet. No ice sublimating, no chaotic outbursts, just a subtle, unexplained acceleration that hinted at forces we couldn't pin down. Was it a fragment of a shattered planet or something more? The debate raged, igniting imaginations worldwide. Fast forward to 2025, and the plot thickens with 3I/ATLAS, discovered on July 1st by the Asteroid Terrestrial Impact Last Alert System. This interstellar comet, estimated at up to 5.6 kilometers in diameter and a staggering minimum mass of 33 billion tons, shattered expectations. Unlike Oumuamua's subtle mysteries, 3I/ATLAS flaunts anomalies that have experts like Harvard's Avi Loeb buzzing. Picture a nucleus rich in nickel, emitting industrial-like chemicals never seen in natural comets, and an anti-tail extending toward the sun, a feature so odd it sparked whispers of artificial design. Its trajectory, hurtling at 68 kilometers per second, aligns perfectly for close solar scrutiny, reaching perihelion on October 30th at 1.4 astronomical units. And those 8 anomalies Loeb tallies? From erratic brightness to possible lateral accelerations, though some dismiss them as observational quirks. It's like the object is daring us to question everything. I remember the first time I read about these visitors. A wave of excitement mixed with a quiet fear washed over me. It's that deep emotional layer. The realization that our home isn't as isolated as we thought. In bustling cities from Tokyo to New York, or quiet villages in Kenya to the Andes, people gaze up and feel the same pull. Let's spread this wonder far and wide. Who knows? Your share might inspire the next great astronomer. As these patterns emerge over the past 8 years, from Oumuamua's fleeting visit to 3IATLAS's bold display, the stage was set for SWAN's grand entrance. Each arrival builds on the last, escalating in scale and sophistication, like chapters in a thriller you can't put down. Transitioning from the whispers of the past to the roar of the present, let's dive into the moment SWAN burst onto the scene. On that fateful September 11th, 2025, the SOHO spacecraft, perched at the Lagrange point between Earth and Sun, was minding its solar weather business. Its SWAN instrument, tuned to detect hydrogen glows in the solar wind, picked up an anomaly that shattered the calm. The readings didn't just spike, they erupted, thousands of times brighter than any recorded baseline. It's as if a distant lantern suddenly became a supernova spotlight, illuminating not just space, but the limits of our understanding. Vividly, I can picture the astronomers' faces, eyes widening behind screens, coffee cups forgotten, as data poured in. SWAN, officially C/2025, R2, wasn't behaving like a typical comet. Instead of messy ice vapors, it maintained a precise, glowing envelope, stretching across 2.5 degrees of sky, visible even to amateurs with basic telescopes. That's wider than 5 full moons side by side, a spectacle that turns stargazing into a communal event. Families in Australia pointing binoculars westward after sunset. Elders in India sharing stories under the same sky. It's a global tapestry of awe. Emotionally, this detection tugs at our sense of security. We've built systems to watch for threats, yet SWAN snuck in from the sun's glare, masked by our star's brilliance. It's a reminder of vulnerability, but also of resilience, the human spirit that turns unknowns into opportunities. What emotions does this stir in you? Comment below with your thoughts. Let's connect over this shared mystery. And if SWAN's stealthy approach chills you as it does me, like the video to keep the conversation alive. But Swan's story doesn't end with detection. Its anatomy reveals layers of impossibility, challenging physics and igniting debates that span continents. Delving deeper, like peeling back the layers of an ancient artifact, SWAN's structure leaves us breathless. Traditional comets are chaotic beauties, ice balls that spew dust and gas as they warm, forming ragged tails. But SWAN, it operates on a different script. Its plasma envelope isn't a haphazard cloud. It's a controlled barrier, deflecting solar particles with electromagnetic precision. The energy involved? Equivalent to a stellar black hole merger, powering a field that could outshine our wildest engineering dreams. Colorfully, envision this: a glowing shield, azure and ethereal, wrapping a core of refined nickel and cobalt, metals purer than any asteroid we've sampled. Not the jumbled mix of cosmic debris, but something that screams manufacture. And its movement? Precise corrections, dodging gravitational tugs from distant planets like a skilled pilot navigating asteroid fields. As of October 25th, with SWAN at about 0.28 astronomical units from Earth and shining at magnitude 6, observers report its stability defies entropy. This stirs a profound emotional response, a mix of admiration and unease. In a world grappling with climate crises and divisions, here's proof of ingenuity beyond our grasp, perhaps a mirror to our potential. It makes me reflect on global unity, from scientists in China collaborating with those in Europe, to backyard astronomers in Brazil contributing data. If this chapter resonates, hit like and subscribe for more cosmic tales. Tell me in comments, does SWAN feel natural or engineered to you? As we connect SWAN to its predecessors, a pattern emerges, one that escalates with each visitor, building tension like a symphony reaching crescendo. Flowing seamlessly from SWAN's enigmas, let's examine the sequence that led here. Oumuamua in 2017. Football field-sized, 30,000 tons. A quick scout zipping by. Then 3I/ATLAS in 2025. Mile-long behemoth, up to 5.6 kilometers across, with over 33 billion tons, with controlled jets mimicking propulsion. Now SWAN, its vast tail and coma suggesting a scale that leaps beyond, its nucleus potentially rivaling or exceeding previous estimates in sophistication, representing a leap to battleship proportions. The timing, eerily coordinated. Oumuamua's brief months. 3I/ATLAS's extended study window. SWAN's lingering visibility, post-perihelion on September 12th. Both 3I/ATLAS and SWAN position for solar observation. 3I/ATLAS at 1.4 astronomical units on October 30th. SWAN's path, allowing detailed views. And in late October, as 3I/ATLAS nears its closest, they'll align in a blind spot behind the Sun from Earth's view, a coincidence with odds defying probability. This pattern evokes deep emotions: hope for contact, fear of the unknown. It's relatable globally. Indigenous stories of sky visitors in Australia echo modern speculations in forums worldwide. Share if this escalates your curiosity. Comment your theories. Let's energize this dialogue. Yet, to grasp SWAN's feats, we must confront the physics it bends. Building on the pattern's momentum, SWAN's engineering defies our paradigms, pushing the boundaries of what we thought possible in the cold expanse of space. Its plasma field hums at over 10,000 gigawatts, more than the global power output, maintained with flawless control that suggests not random cosmic forces, but deliberate design. Temperatures? The core scorching at 100 million degrees, hotter than many stellar interiors, while outer layers remain cool below 1,000 degrees, materials enduring stresses that would vaporize our best alloys in an instant. Analogies abound, like containing a star's heart in a fridge, all while hurtling thousands of kilometers per hour. The computations for course tweaks? Beyond supercomputers, processing gravitational whispers from Jupiter, solar flares, all in real time. But let's layer in the latest insights from Harvard's Avi Loeb, who points to SWAN's plasma envelope as potentially an electromagnetic barrier, not unlike theoretical shields for advanced spacecraft. In his recent analyses, Loeb highlights how such a field could deflect charged particles, requiring energy scales equivalent to black hole collisions. Staggering, yes, but aligned with observations of SWAN's unwavering stability. Emotionally, this revelation hits hard. It's a blend of awe at the ingenuity and a subtle dread of what it implies. Imagine families in remote Siberian villages or bustling Mexican markets, all pondering the same. Could this be technology from afar, guiding these visitors with precision we envy? Loeb's theories add depth, suggesting SWAN's power output rivals entire nations, yet it's harnessed in vacuum silence. Recent data from telescopes like Hubble shows similar enigmas in 3I/ATLAS, with its nucleus potentially generating unexplained accelerations, fueling debates on nuclear-like sources. To expand our understanding, consider the material science. SWAN's nickel-cobalt composition, pure and refined, mirrors industrial processes unattainable in natural formation. Dust mass loss rates, estimated at 0.3 to 4.2 kilograms per second for comparable objects, pale against SWAN's controlled emissions, which appear directed rather than chaotic. This isn't mere sublimation, it's engineered efficiency. In a world where energy crises loom, SWAN taunts us with sustainable power we can't replicate, stirring envy and inspiration. From engineers tinkering in garages to policymakers debating space policy, this pushes us toward innovation. The emotional tapestry weaves tighter, wonder at the universe's secrets, frustration at our limits. If SWAN's physics energizes your imagination, like and share this far and wide. What real-world tech could mimic this? Drop ideas in comments. Your insight might spark the next breakthrough. Now, the trajectory's convergence adds even more intrigue, layering suspense over these impossible feats. Transitioning to the orbital dances that bind these visitors, SWAN and 3I/ATLAS, hailing from opposite galactic origins, sync their solar approaches in this fateful October 2025. SWAN, post its perihelion on September 12th, lingers in visibility, while 3I/ATLAS hurtles toward its October 30th closest point at 1.36 astronomical units, creating a blind spot during key moments as they position behind the sun from our vantage. The math is mind-boggling. Odds of such convergence naturally occurring are vanishingly small, like two strangers from antipodal Earth, points meeting at the same cafe without planning. SWAN dips to 0.5 astronomical units for potential plasma harvesting from the solar atmosphere, while 3I/ATLAS holds at 1.35 to 1.4 astronomical units, ideal for long-term data collection or energy absorption. This precision demands foreknowledge of planetary alignments, accounting for Jupiter's tug and Saturn's sway over decades. Avi Loeb speculates this timing isn't chance. If artificial, these objects might exploit the sun's gravity for maneuvers hidden from Earth during conjunction, perhaps slingshotting or communicating undetected. Emotionally, it's a roller coaster. Excitement at potential discovery, anxiety over unseen actions. Picture global communities. Astronomers in Chile tracking paths. Families in Egypt drawing parallels to ancient skies. Loeb's warnings add gravity. He urges transparency from NASA, hinting at withheld data on trajectories that could reveal propulsion anomalies. Recent simulations show both adjusting for space weather, requiring onboard computation, rivaling AI clusters. To deepen the narrative, consider the broader implications. These paths optimize for solar study, but why now? Coinciding with Earth's tech boom, it feels orchestrated. In diverse cultures, from Navajo star lore to Japanese festivals, such alignments evoke prophecies. This convergence stirs unity, bridging science and spirituality. SWAN's 286-year cycle places its last visit around 1739, amid the Enlightenment's leaps in science and invention. Steam engines emerged, metallurgy advanced, precision manufacturing bloomed, sudden surges that historians attribute to communication, but coincidences with SWAN's passage invite speculation. Could subtle influences like electromagnetic pulses or observed phenomena have sparked ideas in minds like Benjamin Franklin's electricity experiments? Deeper still, a proposed 22,000-year cycle aligns with pivotal human turns. Ice Age endings, agriculture's birth, first cities rising. Egyptian pyramids boast astronomical alignments, defying Eratech, moving massive blocks with uncanny accuracy. Similar feats dot global history. Incan stonework, Mesopotamian math, separated by oceans, yet synced in sophistication. If SWAN or kin visited periodically, perhaps providing inspirational glimpses or indirect aid, it reframes our progress, not as isolated genius, but cosmic collaboration. Emotionally, this bridges generations, evoking pride in our ancestors' resilience, while humbling us with potential external nudges. In today's divided world, it fosters empathy, from African oral traditions of star beings to European Enlightenment ideals. We're all under the same sky. Avi Loeb extends this, suggesting interstellar visitors might have seeded tech leaps, as with Oumuamua's anomalies echoing ancient anomalies. Expanding the view, consider Nostradamus-like prophecies now linked to 3I/ATLAS's approach, blending science with folklore. This isn't mere coincidence. Patterns suggest deliberate timing, influencing events from revolutions to discoveries. In relatable terms, it's like ancestral whispers guiding us, stirring nostalgia and hope. Share this chapter if it reframes history for you. Comment family stories of sky wonders. Let's honor our shared heritage. SWAN's signatures challenge detection, amplifying the mystery. SWAN's electromagnetic cloak hid it until September 2025, despite its size and energy, approaching from solar glare where telescopes struggle. Radio signals, stronger than galactic pulsars, masked by solar interference. Magnetic fields potent enough for satellite disruptions, yet dismissed as weather. This stealth implies advanced camouflage, terrifying in implications. If deliberate, undetected fleets could lurk. Our systems, geared for natural threats, missed this giant until on top of us. Loeb warns of overhauls needed, as artificial objects might employ similar tech, blinding us to unwilling visitors. Emotional undercurrent, vulnerability in our tech-dependent world, from GPS failures to comms blackouts, evoking Cold War-era fears, but cosmic scale. Globally relatable, urban dwellers in Seoul relying on satellites, rural farmers in India using weather apps, all at risk. Recent 3I/ATLAS data shows similar masking, with jets and comas hiding cores. Upgrading demands international cooperation, perhaps new telescopes, or AI detection. This calls for vigilance, inspiring innovation amid unease. If stealth chills you, like and subscribe. Thoughts on defenses? Comments fuel the fire. As we wrap this cosmic saga, SWAN and Kin-Force confrontation, natural wonders or engineered harbingers. On October 25th, 2025, with 3I/ATLAS nearing perihelion on the 30th, the sky holds answers, or more questions. Loeb's hypotheses of alien tech, from motherships to probes, gain traction amid 8 anomalies and hidden maneuvers. Are we safe or observed? Emotionally, it's a call to unity, blending wonder with caution. From prophecy speculations to scientific revolutions, it connects us globally. In diverse lives, teachers inspiring kids in classrooms, elders sharing tales by fires, it ignites curiosity. Future? More visitors like Lemon, C/2025 A6 approach, escalating patterns. This could redefine humanity, fostering peace through shared awe. Like, share, comment. What do you think? Are we alone? Let's discuss, energizing our global community.